In this video, we'll study about projectile motion. But first, let's look at the basics of motion. Consider an ant standing on a pole A and it moves from pole A to another pole B on a piece of string. Its distance, and in this case displacement, will be AB. If the same ant now moves from A to C and then from C to B on strings, then its distance will be AC plus CB, while the displacement will still be AB. Here the motion of ant is restricted to a string, hence it is one-dimensional or linear motion. In first case, the speed of the ant will be the total distance it covered divided by the time it took to cover that distance, whereas the velocity of the ant will be its total displacement divided by the time it took to displace. In second case, the speed of the ant will again be the total distance it covered divided by the time it took to cover that distance. Here the total distance is AC plus CB and the velocity of the ant will be its total displacement, which is AB here, divided by time. Now acceleration will be change in velocity with respect to time. We say that the velocity of an object changes if the magnitude of velocity changes or its direction changes or both of them change. In the case of our ant, suppose a blower blows air on the ant. The magnitude of velocity of the ant increases continuously. Hence, it is an accelerated motion. We can say that the blower accelerated our ant even if it changed its direction of motion. If our ant now moves on a floor, it can travel in two dimensions. Hence, it is motion in a plane. The motion of an object in any vertical plane near the Earth's surface will always be accelerated. The acceleration will be due to the force of gravity acting downwards. Imagine a cannonball shot out of a cannon at an angle theta to the ground. The motion of the ball will be projectile motion. The trajectory of its motion will be parabolic path, and its general equation can be given as y is equal to alpha x minus beta x squared, where the values of alpha and beta can be determined by solving for horizontal and vertical displacements for the given time. Our equation then becomes the time of flight of our ball will be given by this equation, which can be obtained by equating the net vertical displacement to 0. The horizontal range of the cannonball can be given by this equation, which can be obtained by solving the equation for trajectory for x equals r and y equals 0. Maximum height that the cannonball reaches is given by this equation.